heat. Introduction. Heat cannot be seen by us. We can feel the heat by the temperature effect it produces. When heat is given to a substance, its temperature increases and it becomes hotter. For example, when a utensil is kept on a gas burner, it gets heated. Its temperature increases and it becomes hot. Hot and cold. Take 3 bowls A, B and C. Put cold water in bowl A, hot water in bowl B, and lukewarm water in bowl C. 1. We dip our right hand in cold water in bowl A and left hand in hot water in bowl B. Keep the hands in this way for about 2 or 3 minutes. 2. Now take out the hands from bowls A and B and dip both the hands quickly in lukewarm water in bowl C. We will find that the water in third bowl C does not feel equally warm to both the hands. To the right hand, which was earlier in cold water, this lukewarm water appears to be hot. But to the left hand, which was earlier in hot water, the lukewarm water appears to be cold. This, however, is impossible because the same water cannot be hot as well as cold at the same time. Actually, our sense of touch is misinforming us in this case. A hot object has a high temperature, whereas a cold object has a low temperature. The temperature of an object is the degree of hotness or coldness of the object. Laboratory thermometer. A thermometer is a device for measuring the temperature of an object. The range of a laboratory thermometer is generally from -10 degrees Celsius to 110 degrees Celsius. A laboratory thermometer cannot be used to measure the human body temperature. Clinical thermometer. A thermometer used for measuring the temperature of human body is called clinical thermometer. A clinical thermometer has a very short range of temperature from 35 degrees Celsius to 42 degrees Celsius. A clinical thermometer has a kink in its glass tube on the tube sides of the mercury thread. A clinical thermometer has usually 2 temperature scales marked on its glass tube on the 2 sides of the mercury thread: Celsius scale of temperature and Fahrenheit scale of temperature. The normal temperature of human body is 37 degrees Celsius. Transfer of heat. Passing of heat from one end of an object to its other end or from one object to another object is called transfer of heat. Heat flows from a hot object to a cold object. Heat flows from an object at higher temperature to another object at lower temperature. Heat can be transferred from a hot object to a cold object in 3 different ways. 1. By conduction. 2. By convection. 3. By radiation. Conduction. Conduction is the transfer of heat from the hotter part of a material to its colder part, or from a hot material to a cold material in contact with it. Without the movement of material as a whole, the transfer of heat by the process of conduction takes place only in solids. Good conductors of heat and poor conductor of heat. Activity. We take a beaker and fill it half with hot soup. Let us take 2 spoons, one made of metal such as steel and the other made of plastic. Place the metal spoon and plastic spoon in the beaker containing hot soup. After about 2 minutes, we touch the top ends of metal spoon. It feels quite hot, but the top end of plastic spoon does not feel hot. This is because heat from the hot soup flows easily through the metal spoon and reaches its other end. But the heat does not flow easily through the plastic spoon, due to which its other end remains almost cold. This activity tells us that metal spoon is a good conductor of heat, whereas plastic spoon is a poor conductor of heat or bad conductor of heat. We say that plastic is an insulator of heat. Convection in water. Convection is the transfer of heat from the hotter part of a liquid or gas to its colder parts by the movement of the liquid or gas itself. We can see the path of convection currents of hot and cold water taking place during the heating of water by dropping a crystal of a colored substance called potassium permanganate into the water to color it. This can be done as follows. We take a flask and fill it half with water. A small crystal of potassium permanganate is dropped carefully at the bottom of the flask containing water. This potassium permanganate crystal dissolves slowly and forms a purple-colored solution around itself. Heat the water at the bottom of the flask by keeping a burner below it and observe the movement of this hot water, which has been colored purple by dissolved potassium permanganate crystal. We will see the purple streaks of hot water rise from the bottom of flask up to surface of water and then sink downward near the walls of the flask. These purple-colored streaks seen in the water of flask, which is being heated from below, show the convection currents taking place in the water of flask, which transfer heat from the bottom to the top. Convection in air. Fix a lighted candle on a table. Keep one hand at a safe distance above the flame of the candle and the other hand on the side of the flame. We will find that the hand kept above the candle flame feels quite hot, but the hand kept on the side of the flame does not feel so hot. This can be explained as follows. The air just above the candle flame gets heated first. This hot air, being lighter, rises upwards, carrying the heat along with it. The cold air from above, being denser, sinks downwards to take the place of hot rising air. This cold air also gets heated by the flame and rises upwards, and more cold air sinks downwards to take its place. This process of hot air rising up and cold air moving down is repeated continuously. In this way, convection currents are set up in the air above the candle flame, which carry more and more heat upwards. This transfer of heat by moving air makes our hand kept above the candle flame feel very hot. Air can transfer the heat of a source by convection only in the upward direction, because hot air, being lighter, rises in the upwards direction. Air cannot transfer the heat from a source by convection either on the sides or in the downward direction, below the source of heat. This means that no convection currents of hot air take place on the sides of candle flame, due to which the hand kept on the side of the flame does not feel so hot. Blowing of sea breeze and land breeze. The breeze blowing from the sea towards the land is called sea breeze. The breeze blowing from the land towards the sea is called land breeze. Land breeze flows only during the night. Radiation. Every hot object emits, gives out invisible heat rays in all directions. Radiation is the transfer of heat energy from a hot body to a cold body by means of heat rays, without any material medium between them. Absorbers of heat radiations. We take a black painted tin can and a white tin can of the same size and place them on the two wooden blocks separately. Pour equal amounts of water in both the tin cans and fix thermometers in them with the help of rubber corks. The initial temperatures of water in both the tin cans are noted. Their initial temperatures will be exactly equal. We place both the tin cans in bright sunshine for an hour. The heat radiations of sun will fall equally on the both tin cans. After 1 hour, we note down the temperatures of water in both the tin cans again. We will find that water in black tin cans is at a higher temperature than in white tin can. Since the temperature of water in black tin can is higher, it shows that the black-colored tin can absorb more heat of the sun. And the lower temperature of water in the white tin can shows that the white-colored tin can absorbs less heat from the sun. From this activity, We conclude that a black object absorbs more heat radiations than a white object. Since a black object is a good absorber of heat radiation, it also means that a black object is a bad reflector of heat radiation. On the other hand, since a white or silvery object is a poor absorber of heat radiation, it means that a white or silvery object is a good reflector of. Click the correct answer.